So this is the balance equation. Now my question was, why carbon? What are the adverse effects? So we can write adverse effects. Carbon monoxide, this is your carbon monoxide that we take. CO is your carbon monoxide. Mono means one oxide. Carbon monoxide, you can write that carbon monoxide is a poisonous gas. Carbon monoxide is a poisonous gas. Clear? So you need to know that for biology, carbon monoxide is a poisonous gas. It combines with the hemoglobin in the blood. It combines with the hemoglobin in the blood and prevents hemoglobin from reacting from reacting with oxygen. Clear? And prevents, that's why it's very dangerous, and it prevents hemoglobin from reacting with oxygen. Are we together? Carbon monoxide.
Yes.
We said carbon monoxide reacts with hemoglobin. And when it does that, now it prevents the hemoglobin from reacting with oxygen. So we don't want that. We want to try eliminate as much carbon monoxide as possible. Clear? Mr. Aguda? Besides carbon monoxide, we also have sulfur. Next one is sulfur dioxide. We're talking of the gases that cause pollution. Sulfur dioxide. Sulfur dioxide is produced from combustion of fossil fuels and natural gas. Combustion of fossil fuels and natural gas. Combustion of fossil fuels and natural gas. E.g., your zinc blend, which is zinc sulfide, reacts with oxygen in the high temperature, forms zinc oxide plus sulfur dioxide. To the sulfurs, 2, so that this is balanced. 2, so that I have 2 zinc, 3 there. Clear? Maybe?
Yes.
Now, adverse effects. The sulfur dioxide reacts with water vapor. It reacts with oxygen and water vapor in the atmosphere to form sulfuric acid. Clear? The sulfur dioxide reacts with oxygen and water vapor in the atmosphere to form sulfuric acid, which is known as acid rain because it will be in liquid state. Clear? But it's less concentrated there's so much water vapor in the atmosphere. Clear? So let's look at the chemistry. The chemistry of what we are saying is that we have sulfur dioxide that is produced, reacts with oxygen plus water vapor in the atmosphere to produce sulfuric acid, but it's in liquid state. Clear? Making sense? So that's your chemistry there. For formation, this is what we call acid rain. Are we together? They ask you to write an equation for formation of acid rain. That's it. Happy? Acid rain.
Yes, sir.
Now, the acid rain causes corrosion to metal structures. Acid rain causes corrosion to metal structures, buildings, Statues made of carbonate rocks. Pollutes water surfaces. Pollutes water surfaces. Clear? Reduces the soil pH and affects growth of crops. Reduces the water soil pH and affects the growth of crops because most crops do well in alkaline conditions. Because most crops do well in alkaline conditions. Are we together? Making sense?
Yes, sir.
Now, next one is write oxides of nitrogen. Oxides of nitrogen. Clear? Nitrogen does not easily react. Nitrogen does not easily react. Nitrogen does not easily react. Karen, I hope you are writing notes. Nitrogen does not easily react because of the triple bond that I've shown you there. Because of the triple bond between the two nitrogen atoms in a nitrogen molecule. Because of the triple bond between two nitrogen atoms in a nitrogen molecule. Comma. Which means it needs very high energy. It needs very high energy to break. Which means it needs very high energy to break the bonds. It needs very high energy to break the triple bond. Clear? Next point. Nitrogen only reacts with oxygen under high temperatures. Nitrogen only reacts with oxygen under high temperatures. Under high temperatures, e.g. in car engines and during lightning. Clear? E.g. in car engines and during lightning. High temperatures. Clear? Are we together? Kuda?
Yes, sir.
Adverse effects. Adverse effects. Oxides of nitrogen also lead to formation of acid rain. Oxides of nitrogen also lead to formation of acid rain. Oxides of nitrogen also lead to formation of acid rain. Who did we lose? Did we lose someone there? I was asking, did we lose?
No, sir.
It looks like someone was kicked out of the lesson. Anyway, Kieran, you are there?
Yes, sir. It's just I kept on getting disconnected, sir.
Okay, so now let's look at the equation. Huh? So we want to see how acid rain is formed. Huh? So I will give you, so it's almost a similar equation, but it's slightly different. So nitrogen oxide reacts with oxygen in the atmosphere plus water, more like a similar equation. Huh? But the acid rain here is not sulfuric acid, it's nitric acid. So again, it's acid rain. Huh? So the same effects, destroying buildings and other. Clear? Are we together? 4 here. 4. 4 nitrogen, 4 nitrogen, 4 hydrogens. So we need 2 here. So now we have 12 oxygens, 8 oxygens, 10 oxygens, 12 balance. Clear? That's the balanced equation there. That's how acid rain is formed from that. Clear? Next point, nitrogen. Next point is that nitrogen monoxide. This is nitrogen monoxide and nitrogen dioxide. Nitrogen monoxide and nitrogen dioxide are formed. Nitrogen monoxide and nitrogen dioxide are formed when nitrogen and oxygen react at higher temperatures. When oxygen and nitrogen react at high temperatures. Clear? Cars are fitted with catalytic converters. Cars are fitted, you need to know that, with catalytic converters. In their exhaust systems. To convert these harmful gases into harmless forms. To convert these harmful gases into harmless forms. Clear? To convert these harmful gases into harmless what? Into harmless forms. Clear? To convert these harmless gases, we're talking of carbon dioxide and the nitrogen dioxide, they have to be converted by catalytic converters into harmless forms. Clear? So that they cause less pollution. Now, the catalytic converters are made of transition metals, are made of transition metal catalysts, or they contain, sorry. The catalytic converters contain transition metal catalysts, especially platinum. The catalytic converters contain transition metal catalysts, especially platinum. Clear? Let's look at now subheading catalytic converters reactions. Catalytic converters reactions. catalytic converters reactions. Catalytic converter reactions. Number one, you can write that carbon monoxide is oxidized to carbon dioxide. Carbon monoxide is oxidized to a less harmless, carbon dioxide by your catalytic converters. Clear? So the reaction is simple. It's simply carbon monoxide plus oxygen to produce carbon dioxide. 2, 2. Sorted. Clear? That's the first thing that happens in a catalytic converter. Then you can write that nitrogen oxides, which you also want to prevent acid rain. Nitrogen oxides are reduced to nitrogen, gas. So example, NO. Sorry, let me not put it to others, it confuses you. NO is converted to nitrogen plus oxygen then the second equation, NO2 again is converted to nitrogen, and this does not easily react, so it's safer like that. Clear? That's what happens in a catalytic converter. Are we together? Making sense? What happens in a catalytic converter?
Yes, yeah.
Let's look at another pollutant, compounds of lead, PB. Where do you get that source? Under that sources, old water pipes, old paints. As in painting, old paints. Petrol in some kind of racing cars and very old engines. Petrol in some kinds of racing cars and very old engines. Clear? The adverse effects causes significant damage to central nervous system. You can write that lead compounds cause significant damage to central nervous system, especially the young infants. They're the ones that are most affected by this. The last thing for today, for chemistry, rusting of iron. Clear? Rusting of iron. Rust is a chemical reaction. in which iron reacts with the water and oxygen. In which iron reacts with the water and oxygen to form a compound known as iron 3 oxide. 3, we write the 3 in Roman numerals. It stands for the oxidation state of the iron. So if I'm writing, I write iron in Roman numerals 3 oxide. Clear? Iron 3 oxide. And by the way, that is what we call rust. Yeah? Clear? Iron 3 oxide. Clear? Hydrated, by the way. Hydrated iron 3 oxide. Hydrated, it means it attaches. It's not, this is anhydrous, yeah? But it's not like that. Huh? When rusting happens, so let's look at the equation here. I'll write the equation. Let's write the word equation first. Iron plus water plus oxygen will give us hydrated, means it is water, iron 3 oxide. Chemistry, iron is Fe, you should know that, and it's a solid, plus H2O, which is a liquid, just writing the states here, liquid L, plus oxygen, which is a gas, gaseous state, to form Fe2O3. Then it can attach itself to many water molecules. I'll put X, H2O. Then there I put X here. Whatever the water molecules are there, they will balance there. Clear? Follow me? Then I've got 2 here on the ions. So let's put 2 there so that we've got 4 ions. We put 4 here. Then on the oxygens, 3, 6, so we put 3 here. It's balanced like that. You can write that equation there. Clear? And this is what we call rust. Making sense now? We've learned something new. Which means if any of those 3 are not there, rusting will not take place. Clear? If there is no water, if there is simply an ion just exposed where there is no water, rusting will not take place. Huh? If there is no oxygen, rusting will not take place. Are we together? Is that making sense? Which means if you put an iron nail underwater in a test tube, then you put oil on top. Oil prevents the oxygen. Huh? So it means the rusting will not take place. Huh? Even if you leave it for days, for years, that nail will still be the same because there is no oxygen. Clear? All those 3 must be present for rusting to take place. Are we together? The iron, the water, and the oxygen. Let's talk of prevention of rusting or rust prevention methods. Clear? Number 1. Rust can be prevented by coating iron with metals that resist corrosion. By coating iron with metals that prevent corrosion using electroplating. Are we together? Galvanizing is a process where iron is coated with a layer of zinc. Where iron, is coated with a layer of zinc. Clear? The zinc coat can react with oxygen and carbon dioxide in air. The zinc coat can react with carbon dioxide and oxygen in air, forming zinc carbonate, which further protects the iron. Are we together? Are we together there?
Yes, sir.
Any questions so far? That's all you need to know when it comes to, we've looked at, I think we looked at, remember we looked at sulfur and its compounds. We looked at nitrogen and its compounds. We were doing all in inorganic. Then we looked at manufacture of iron, Haber process. Where we did look at manufacture of aluminium, it's okay, we'll look at that. Then we now looked at air and its compounds. Then we looked at air pollution. Then we'll look at tomorrow, everyone, we'll look at metals and non-metals, the general properties. So that we wind up, that's tomorrow. Then the next chemistry lesson, I don't know whether it's Thursday or what, we start electrolysis and redox. 2 lessons we should be able to cover electrolysis and redox. Clear? Are we together? Electrolysis and redox. So by the end of mid-June, we should be starting again organic. We should be done with the syllabus. Because it means it's like restarting organics, just making sure people that didn't understand organic. I'm talking of, because chemistry is divided into 2. We have the organic and the inorganic. So all we are doing is inorganic chemistry. We even look at periodicity, group properties, reactions. It's under inorganic. It was divided into 2 sections. Clear? Are we together?
Yes, sir.
Then some did not submit their chemistry, because from the workbook I had said go up all the way to 2.1. Was that 2.4? Unit 2.4 in the chemistry, so that we revise. Maybe we'll also look at that. We'll see tomorrow what it goes. Maybe we'll reserve 20 minutes for revision. Most people are confused with chromatography, how to find RF values. Certain people don't even know that. Anyway, are we together?
Yes, sir.
Then
Sir, also what lesson is next?
for the physics now, I don't want you to go ahead of the other class. So physics, you're supposed to do so that we revise tomorrow. I want you to Could I have done up to what? Did you done momentum? I don't remember you doing momentum because we want to revise on things that we've covered. Had you done up to momentum? I think you had left the momentum part on the physics.
I think I did up to momentum.
Are you sure? Let me check. So again on physics there, what we have done, we are supposed to play around with formulas. If you're stuck, we help you tomorrow. So if remember, people had done 2.1 and we revised that together. 2.3, we revised that together. 2.4, we revised it together. 2.5. So I think 2.5. Did you revise 2.5? .6 or so then. So I think it's from 2.6. So that might have done that. I'm thinking we revised this. So what we didn't do is 2.9. Okay. So 2.9. 2.9, Kiran. 2.9 to I want you to do that 2.9 to 3.3. 2.9 to 3.3. Good I there?
Yeah, so this is for physics.
Yes. Today. Then tomorrow we are going to revise it. 2.9
Yes,
to 3.3. Karen 2.9. We've learned everything. If you're stuck, you check your formulas. If you're stuck, we see tomorrow. 2.9 to 3.3. So that we are not really ahead of the other guys. We are on the same page. So can someone send on the school group, even those that are doing online or physical, tell them that they need to do their physics homework before tomorrow, 2.9 to 3.3. Karen, you got that down? You lost him. Tandy, making sense?
Yes, sir.
Yeah, so maybe send on the school group then. Even those that are doing physical, they need to do that. And we pick it from there. Okay. Because we need to master those topics. Okay. We see you later.